Here's the challenge. We need to increase carbon capture 100,000-fold by 2050, which means we need direct air capture solutions that can scale fast. That means low OpEx, low CapEx, and a mature and scalable supply chain to meet demand. DACLab's breakthrough technology checks all of these boxes by combining patent-pending core DAC process innovation with full end-to-end engineering hardware design for scalable manufacturing. Our core DAC process design was developed over 3 years of rigorous R&D in collaboration with the Chemical Engineering Department at TUEN. Our approach reduces energy needs while maintaining low pressure drops, with a unique heat pump integration enabling our system to work in any environment, and a plug-and-play architecture that will allow the use of next-generation adsorbents, giving DACLab a clear pathway to 800 kilowatt-hours per ton. Our end-to-end engineering hardware design eliminates the need for precision manufacturing and increases operational lifetime. It is built with only U.S. mass-manufacturable parts and uses globally available, inexpensive, and long-lasting adsorbents. Our prototypes are fully operational, developed in partnership with DACWorks, whose team has over a decade of experience designing, building, and deploying carbon capture systems. With an innovative yet practical technology and a carefully curated team of expert consultants and key CDR industry partnerships, DACLab is committed to capturing 1 million tons of CO2 by 2030.